You might have noticed, when we heat one end of an iron rod, after some time, its other end also will become hot, right? That is, the flow of heat is unidirectional from higher temperature to lower temperature. Similarly, water flows naturally from a higher level to a lower level. In fact, all naturally occurring processes, whether chemical or physical, will tend to proceed spontaneously in one direction. Why is it so? What is the driving force for these processes? What determines the direction of these processes? In this video, we learn about the criteria for a process to be spontaneous. First of all, consider ice kept at room temperature. As time passes, you can see ice will melt into water. Such processes which proceed without any external aid is said to be a spontaneous process. Or in other words, you may say spontaneous process is an irreversible process and they may be reversed only by some external agency. Note, the term spontaneity means having the potential to proceed without the assistance of an external agency. Then what about a non-spontaneous process? Well, non-spontaneous processes occur only after supplying energy to the system. Now let us consider some spontaneous chemical reactions. For example, the burning of octane in presence of oxygen. This is an exothermic process. Hence, the enthalpy of products would be less than that of reactants. Therefore, we may conclude that reaction is spontaneous because it is accompanied by a decrease in enthalpy. Or in other words, you can say that a decrease in enthalpy is a criterion for a process to be spontaneous. Next, let us consider the decomposition of nitrogen pentoxide at room temperature. This reaction, though spontaneous, is endothermic in nature. The enthalpy of products is greater than that of reactants. That is, there is an increase in enthalpy, right? So, do you think that an increase in enthalpy is also a criteria for a spontaneous process? Well, from the above two reactions, we may say that spontaneous reactions are generally exothermic in nature. However, the endothermic process may also be spontaneous. That is, the decrease in enthalpy is not the only factor determining the spontaneity. Then what are the other factors that drives the spontaneous process in a given direction? Let's see. We may examine a spontaneous process in which the change in enthalpy is zero. Consider a container with two non-reacting gases separated by a partition. If you remove the partition between them, then the gases will diffuse into each other spontaneously and completely. At this point, you may say that the system is unorganized or the randomness of the system is increased. Thus, the tendency for a process to be spontaneous depends on the tendency of the system to acquire randomness. Thus, you may say that the tendency for a decrease in enthalpy and or the tendency for an increase in randomness is the criteria for a spontaneous process. The enthalpy changes of a system can be measured calorimetrically. Then, tell me, how will you measure randomness? Well, randomness or disorder of a system is expressed by a thermodynamic function known as entropy. If you compare the three states of matter, the solid state has the lowest and the gaseous state has the highest randomness. This means solid state has the lowest entropy and gaseous state has the highest entropy. Now let us try to quantify entropy. Entropy is a state function and it is independent of the path by which it has reached that state. Hence, the change in entropy can be written as the difference between the final state and the initial state. Next, let us consider how heat and entropy are related. Whenever heat is added to a system, it increases its molecular motions due to increased kinetic energy. This results in increased randomness in the system. When the same amount of heat is added to a system at a lower temperature, it causes greater randomness than that is added to it at a higher temperature. This suggests that entropy change is inversely proportional to the temperature. That is, for reversible reactions, the change in entropy is the ratio of heat absorbed reversibly to the temperature. Now let us see how entropy is related to spontaneity. Consider an isolated system where there is no exchange of matter and energy. When the partition is removed, the gas mixes spontaneously and the entropy increases. Thus, you may say that for a spontaneous process in an isolated system, entropy is positive. Note here, the gas mixtures continuously until a uniform mixture is obtained, or you may say that the mixing continues until an equilibrium is reached. Next, we may consider a non-isolated system. For example, a cup of tea kept open. Here, the total entropy change is given by the entropy of the system and surroundings taken together. And randomness or entropy increases until the equilibrium is reached, that is, till the tea attains room temperature. Thus, when a system is in equilibrium, the entropy is maximum and the change in entropy is 0. We have also discussed that for a spontaneous process, entropy is greater than 0. However, in the case of an irreversible process, total entropy is not 0. Before winding up, I have a question for you. You might have learned about rusting of iron, right? Rust is a formation of hydrated ferric oxide by the reaction of oxygen and iron in the presence of water. My question to you is it possible to isolate iron from rust? That is, whether the reverse reaction is possible or not. In fact, a decrease in enthalpy or an increase in entropy alone cannot determine the direction of spontaneous change. That is, there is yet another factor which decides the direction of a spontaneous reaction, and that we will learn in our next video. Now let us summarize what we have learned.
Manorama Horizon. Learning made simple.